Hello and welcome to this 5-minute short, all about air in Physpack. So air, the most ubiquitous of materials, it'd be hard to live without it. And obviously every now and again, we would need to model it. So how do we do this? We would go to our component list, we type air in, it's there, we can bring it across, and then we can do a specification. So we'll have a look at the specification. So here I've just got a pressure range, a temperature range. Press close. I'm going to calculate the active component. Physpack is going to go away, look at this and think about this and try and work out these variables for air. So we can see the bar is nearly done at the top. And then lo and behold, we have a bit of a problem. We have no stream data. We have no vapor data or liquid data. And if you go into messages, it's a wonderful sea of red. What is happening here? Because that's not exactly what you want or useful. So if we go to our VLE tab, you can see that we're in PSRK. So this is this default VLE method that we've put within Physpack because it's a good all-rounder. But what the P part of SRK means, it's got some activity coefficients and it accounts for a non-ideality, but it doesn't know what those parameters are for air because air isn't a single component. It's a mixture of many, many things. So there is no parameters, no activity coefficient. So the PSRK can't cope, can't understand the component air, which is why you got all the red, the sea of red coming back saying this has failed. So what can we do? There's a couple of things we can do because obviously we want to model air and we can model air. So if I go into my VLE methods, we can choose a different VLE method. This is air, so just a normal cubic type VLE method will do. And actually we'll go SRK just to knock the P bit off. Go back to my feed, calculate active, and this will calculate away. Again, have to wait for it just to chunk through the numbers a little bit. But because this hasn't got those activity coefficients, it is just a cubic equation. Lo and behold, it can create our data for us. So we've got our stream data, and then the messages look an awful lot neater. So that's one way we can do it. So if you are just doing air, then that's a way of doing it, and probably the way most people will do it. So just go in the VLE method to change the VLE method. But of course, there's another way you could do this, and you could actually create the components of air. So you can go through, find a reference. I can't remember, it might be Wikipedia, this particular composition of air off the internet, and we can type it in. Now that is going to be a little bit bothersome and tiresome, but you can save these. So we could save this. We can save it as a stream type. We can call that air. And then every time we want to use air, then we can bring it in. So we could make it relatively simple. That's just saving it as a stream composition. Now we've got a decent number of the components of air. I'm sure there's even more tail if we really want to get into it, but that seemed to be a sensible list. Again, we've got PSRK, so we've left it to the default, and then we can press calculate active. Now this is going to go off and think about it, but we're using PSRK, but it's got the activity coefficients for these different components. These are real chemicals now, not a made-up thing called air. And if I bring the results across, you can see we've now got a full set of results and very few messages. So it all works out quite nicely. And then if we can do, let's bring the stream up. We can bring so this was the previous one. That's air. That's the components. Let's have a quick look at density, just as an example. You can see we're very, very close. So yes, it's slightly different, but I think we can forgive ourselves 0.0002 kilograms per meter cube. It's fundamentally the same answer. So that's a way of dealing with air. It's a little bit off-putting when you first put the component air in, press go, and you get a failure. Two options. One, just go into the VLE method, change the VLE method, SRK, Payne Robinson, whatever you want to do. a nice simple equation of state. Alternatively, you can put the components in, say that's going to be a bit tiresome doing that all the time. So create it once, save it, and every time you want to use it, you can just pop it into Physpack or any of the other Pell programs. Thank you very much.